Hey everybody, thanks for coming to our talk. This is the last talk of the day, so I appreciate you sticking through. My name is Patrick Coffey. I'm a software engineer at Four Kitchens, JavaScript engineer to be specific, and I come from Austin, Texas.
And my name is Luke Harrington. I'm from San Diego, California. I'm also a web chef at Four Kitchens.
Luke,
This is going to be awkward. Okay, so today what we're going to talk about is virtual reality, specifically four things, all right? So specifically virtual reality and its history, because I think everyone thinks it's a very new thing, but it's not. Also, building and distributing virtual reality experiences over the web, specifically, so web-based VR.
Yeah, and we're going to dig a little bit into AFrame and React, which are two tools that can be used to quickly create really strong WebVR applications. And then we're going to delve into Drupal as an API to serve WebVR content. What is virtual reality? Actually, yeah, let's do that. Thanks. What is virtual reality? Put simply, it's a three-dimensional space that's generated by computer software. People generally enter a VR experience by putting on a headset of some sort, like an HTC Vive or an Oculus Rift or a Google Daydream. I think most of you are probably familiar with that and may have experienced it, may actually even own one. And when people enter that experience, put that headset on, they're presented with a field of view that contains a series of geometrical elements that they can then interact with, usually with a controller, sometimes with their own hands. They've got some hand controllers now. It's pretty neat. It sits between your knuckles. People have been thinking about VR for a long time. They've been dreaming about it. We have wanted to create virtual experiences that can captivate an audience or a set of users, really since, the dawn of the century, honestly. The first concepts of virtual reality that sort of mention goggle-based systems come from science fiction. Stanley G. Weinbaum's 1935 story of Pygmalion, thank you, spectacles, describes sort of a goggle-based virtual reality with a holographic recording of sort of fictional experiences. And really early on in the 1950s, Morton Heilig created what's called a telespheric mask, which was actually a mechanical device that delivered 5 short films that stimulated viewers' senses of sight and sound, and smell and touch as well. So people would stick their heads into this thing, and it would kind of like release some smells, create some pictures. I don't know, it was really weird. So you can see this picture here, right here. If you look at this, that's his telespheric mask. We also have the Sega Genesis and the ZA Production SAS Cube. These are all like really clunky, low-res, high-latency, astronomically costly devices that are powered by really, really expensive non-portable computers, or in some cases, like in the telespheric mask, a bunch of really complex non-manufacturable mechanics that you'd have to sort of build yourself over and over, which is a lot of work, as you might imagine. And it's really not like this anymore. We have better technology, and we've been experimenting with a lot of new initiatives and ideas around VR.
So as the saying goes, web is eating software, and web is eating VR now. So WebVR is a relatively new idea. WebVR essentially, or web-based VR it's also called, is the idea that virtual reality experiences and applications can be consumed and delivered just as a standard web page. So it's gaining a lot of momentum. The spec is being written and implemented at the same time, and in browsers there's a lot of demand for it. And there's a lot of tooling being built around it too. So there's a lot of reasons why WebVR is gaining a lot of momentum. Mostly, WebVR is important because for the same reason that like standard web pages and web applications are important, WebVR is, and it's access and democratization, that's a hard word, of information. So anyone that has a web browser, which is a lot of people these days, can now experience VR. And that's saying a lot coming from this giant mechanical machine that you had to stick your head inside of, 50 years ago. So the same browsers that people use every day to, go to New York Times, to go to Facebook, can now be used to deliver and develop WebVR applications. So this is an example of one of the newer devices out. This is a Google Daydream. That headset is $80, and that's a Google Pixel phone. Also, if you don't have a Google Pixel or a Google Daydream, all you need is like a piece of cardboard practically. Actually, Google has developed this thing called Google Cardboard that allows you to basically fold your smartphone up into the viewer and hold it up to your face. So you don't need a $2,000 computer, you don't need an $800 headset to experience VR. All you need is a phone and maybe like a piece of cardboard. So enough talk. Let's actually look at what it takes to build out a VR application.
Totally, and one clarification is you can actually build applications for the $2,000 computer and $800 headset in WebVR, and in phones, you can sort of build applications for the whole plethora of devices that are available and all of their controllers, and support for those devices is rapidly rolling out. So let's see what it looks like. So this is a very, very simple WebVR application built using a framework called AFrame. And this is an entity component framework for defining WebVR applications. AFrame surfaces a declarative interface for sort of defining geometrical entities, and it's a really, really basic system for creating these WebVR scenes that have geometrical components. And if you take a look here, you'll see a couple of things. First, we have a scene that we're defining, which just basically says we have a 360-degree environment. Then we have several geometrical components that have things that you would expect them to have, like a position, Cartesian coordinates that describe where they are in the scene, rotation, which is another set of coordinates that describe how it's rotated, color, width, height, radius, scale. All of these things are are definitely going to be familiar with you or to you if you've worked in gaming at all, and they're very reasonable, very basic geometry. And so we can define these different types of element. AFrame will take these and then render them using Three.js against a canvas. The last thing that we see is a sky, which is sort of like if you're familiar with game development, there's like a backdrop. It can be a 360-degree equirectangular photo or video, or it can just be a color. And it sort of just sits behind your terrain and your other three-dimensional objects that you have sort of sitting in your AFrame scene. And if we render that code, we get something that looks just like that. And as I mentioned, this can be loaded and rendered on any browser that supports WebGL. There are polyfills for browsers that don't actually support the WebVR spec. So basically any browser that has WebGL and has a graphics card that can render WebGL can render this. And some mobile browsers actually support opening this in a stereoscopic view. If you press this button right here, it'll sort of split between two little panes, and you can put that into a cardboard or a Daydream and see it as if it's three-dimensional. If you have a headset like the HTC Vive or the Oculus Rift that supports room scale, you can actually walk around the geometric components and see the other side, see how the light affects it at different angles and that sort of thing. So this is really simple, right? We just looked at a couple of lines of code that were very reasonable, and it's just HTML, right? But that doesn't really support any interactions. What if you actually want to make a game or something that does something functional? What if you want your users to be able to actually do some things with the geometrical components that you've already defined? Well, we can do that. We can build something that makes an interactive experience for users and can be used on a variety of devices. And we can build full-blown applications that utilize all of the 360 degrees, all of the VR space, simply with a web page. Now, when we talk about doing that, we're talking about building something that's a little bit bigger. And AFrame is an entity component-based system, so you can define interactions and different components in a very reusable and modular way, and that's great. But something that we sort of discover when we do that is that we might come up against some issues of like scalability, maintainability, code reusability, and that sort of thing. And so in that way, we kind of want to use a different pattern, a different tool set that has sort of solved those problems in a very, very elegant way. And since we're just working on the web, we're using web technologies, we can use other web frameworks such as React to solve those problems for us. And we can use AFrame with React so that we have AFrame doing a bunch of 3D rendering and sort of abstracting that problem away, and we have React handling all the things that it's good at, like being composable, having state level or component level state management, and data binding tools. This also opens you up to an ecosystem of state management tools that allow you to keep track of the global state of your application, which becomes really important when you're tracking a bunch of different components that might want to interact with each other. You might, you as a user in WebVR, you're a component, you're a camera, so you might want to track your own position. When you have controllers, those are also components, so you have to define your own interactions with that, with all the different components. And managing all of that can be complicated, and having that all the different systems that we have available to us for managing global state then becomes available to you if you use React. So here's a React version of the application that we were looking at earlier. I realize this is a little small, so I'll apologize. I'll walk through it. This is basically just a React component. We have some initial state that we set. We have a method that updates state. If you're familiar with React, this is going to be boring to you for about a minute. And then we have a render method that goes through and renders a scene and an entity. And these things you might notice are capitalized, and they have this primitive property here, a box, and this one doesn't have primitive because it's just a scene. But that basically is using something called AFrame React. And AFrame React basically allows you to define AFrame components in React, and AFrame React components will then take those properties and delegate them directly to AFrame, which prints them in WebGL. So you don't have to print it to the DOM and then have the DOM talk to AFrame. You circumvent that whole layer. And by doing this, you actually effectively allow AFrame to handle what it's good at, 3D rendering, and you allow React to handle what it's good at, being composable, having good state management, and being a really excellent way to organize your code base. So the other thing that you'll notice on here is that we have an event property here. If you're familiar with React, you'll say that's not what I'm used to. That's not an on-events method. That's just an events property. And that's because this is just being passed directly to AFrame. We don't want React handling events. We don't want this being printed to the DOM and DOM elements getting these events. We want those actual 3D geometrical components getting the events. So we have this property here, and it takes an object, which is a click event, and then we pass that a function, and when this function is called, we call this update color method, which sets the state to a random color that it calculates on the fly. And if you look at this property here, we're mapping the color of this object to the color state, so we deconstruct it here. So whenever this is clicked, this will call update state. It resets the color state, and it will change the color of this box. Can you go to the next slide? So that gives us something like this. And this is really simple. This is not a complex interaction, but you can imagine that if we can track the state of color in that component so easily and so cleanly, we can track the position, we can track the rotation, and we can do that with all of these components. And if we have a state management system that's handled on a global level, we can allow those components to interact with each other and respond to each other's different state properties. So this is a really strong pattern for defining three-dimensional environments and VR spaces, and we sort of need a cohesive system like React if we're going to make something complicated, if we don't want to lose our minds, 2 days into the project. So yeah, then we're going to talk about how we actually store all of this state in Drupal and make it persistent using Drupal as an API.
Right, so I'm sure many of you at this point have been like, what does this have to do with Drupal at all? Why are you giving this presentation? And that's okay, I get it. But we're going to get to that now. So as you've heard many times in this conference, that Drupal does something really well, and that's modeling content. Like the consistent thing that you saw between Reservoir and Contenta were, hey, we're going to leave the content modeling portion because that's really like a super powerful part of Drupal. And so when it came to modeling data in VR, there was no reason why we couldn't model that with something that does it really well, and that's Drupal. So we're going to go into a little bit more specific example here, and that would be a VR tour experience. So let's imagine what this tour might look like. So we have, we enter the experience, right? And we see these tiles here. These tiles represent scenes inside of the experience. And so what we're going to do is we're going to enter a scene and interact with it. We're going to be told a story and kind of immerse ourselves in a new environment. So let's enter Mike's workshop. fellow web chef. So we're going to enter Mike's workshop, and we're immediately immersed inside of Mike's workshop. We can pan around, we can look, we can stare Mike in the eye awkwardly as he stares us back, and we can interact with these icons here. So you see like these information icons. We can open one of those maybe and get some information on one of those really cool paintings that Mike has up on his wall. And then we can close that, and we can navigate away and be linked off to Mike's office, and so on and so forth, right? So what does this specifically look like modeled? And simply put, it can look like this. Experiences have icons, those icons you saw, and ambient sounds. They also have an initial scene, maybe, for like the entry to the tour, and then also obviously references to scenes. A scene is going to have a title, a photosphere image, like 360-degree image, and then a slug, so that routing can be taken care of in the front end. And then each scene is going to have many components, which are where really the power behind the tour, which is the types. So you could have like a modal type where you interact with it, and a modal pops up like we saw. You could have a sound where a sound is played when you interact with it. Maybe even like a 3D model could be modeled, and then obviously we're going to need an X, Y, and Z position coordinate. Also, we're going to support a scene link so that components can link to other scenes inside of the experience, and we can kind of like create this tour, this tree of kind of like choose your own adventure for the tour. And honestly, like this was made. Exposing this model was made very, very easy by all the hard work that the team has done. And I mean, I think if you aren't convinced by now, by the end of the day, I don't know who's going to convince you. This is really powerful stuff. So really, we have one slide to show about consuming data from Drupal, and that is something that's too small to read, but it's using the JSON-API module in coordination with the Waterwheel module to go fetch the experience bundle off the node and include a lot of different related entities like the scenes that we talked about, the ambient sounds, the components that are on the scenes, and from there we can just let the front end do its job. So this is a single call to build out an entire VR experience here. But we didn't want to stop at just viewing VR experiences. We wanted to make like a VR CMS kind of experience as well.
Yeah, absolutely. We're using Waterwheel to grab data from Drupal, and we also use it to patch back to Drupal. We've been working on something that we call the VR editor. Sorry, this is a little blurry. The video hasn't started, and it won't start it for a minute. But basically, what we're doing is we're using these tools, React, Redux, and an AFrame, to create a WebVR experience that allows you to also edit that experience. And we pull all this data from Drupal. We pull the scenes, the experiences, the components that are within those scenes, the photospheres, all that stuff is stored in Drupal and expressed in the content model that Luke was showing you. We pull that in, and then we render it, it's basically that simple. We then respond to different interactions, and we take the data from those interactions. Like, for instance, if you drag and drop an element and place it somewhere, we take its new X, Y, and Z coordinates and patch that back. And I'll just go ahead and play this. Duped. There you go. So you can see, I can sort of navigate around this scene and see the different components that are there, I can go ahead and choose a different tool from the sidebar. For instance, dragging and dropping, and I can grab an element and sort of like pull it down, and it states being patched back to Drupal. That's now stored, you can also grab another tool, the selection tool, and you can modify properties of this dialog, for instance. You can change it, and once you press the save button, this is patched back. And then Drupal is actually the persistent store for this WebVR application. And this works really well. We were able to build this out with a pretty high level of efficiency. I mean, I think there were some struggles, I think, with especially responding to events, but AFrame's been getting a lot more mature, and they've been doing a lot of work in regards to supporting different types of controllers and making those interactions a lot more useful and solid. So, yeah, this is a full-fledged. Thank you. Thanks. Yeah, so this is a full-fledged VR editor, and the cool thing about this is using web tools like React is that we're rendering this VR scene with React along with editorial experiences on the side, but the same thing that renders the scene for the editor can render the actual scene for a user. So we don't have to write any extra code to sort of like present this. It's just sort of there. And the other point that Luke likes to make is that this is actually inline editing for virtual reality, backed by Drupal, which is pretty neat. I mean, inline editing for fields is still something that we, try to support sometimes, and it gets a little bit rough. So that's pretty nifty, I think. And I'm really surprised by, the maturity of the different tools that we're using, and really all the momentum that's been sort of funneled into WebVR and the surrounding tools like React. I think we're actually using Material UI to build out the interfaces. So, yeah. We have a couple of resources here. We didn't get to dive too much into AFrame or React or any of those things because this isn't a presentation about those. It's a very short presentation about the combination of them and what you can do with them. So if you want to get started, we have AFrame boilerplate, which is basically our take on how you should structure your applications. Using React, it also has quick events, all the things that you saw. Basically in the earlier in the presentation with the clicking of the box and stuff, all that works. So if you want to clone that and get started and start building things, that's where you need to go. And then you have ReactVR.
Right, yeah, and we didn't have time to cover it, but AFrame is not the only framework out there for building VR experiences. Facebook, in coordination with Oculus, has also released ReactVR, which is still very new, and we have an example up on our GitHub as well. And I actually just wrote a blog post. If you go to my Twitter, just Luke Harrington on Twitter, I have it pinned. You can kind of check out the difference between the two frameworks and the trade-offs. So yeah, check that out. Also, if you're interested in trying out what this actually feels like, we have some cardboard viewers in the back. Todd is waving. So come check it out, and we have some experiences built out that you can kind of try for yourself. So other than that, I think we're done. Do you have any questions? Sure.
Have you experimented any with user interaction, and if so, is there any kind of latency?
We have not. I have not personally experienced with multi-user interactions in VR, WebVR specifically. I know that some people have done it. I've actually checked out some WebRTC-based experiences, and I didn't experience too much lag. Although I will say, in general, depending on the device that you're running WebVR applications on, it can get a little bit low frame rate, I guess, just rendering the object models. So if you have 10 users and they all have an object model, it's not necessarily the position that you're getting and having to render that position that's the problem. It's just all the object models that you're having to print. If you're doing that on a phone, it doesn't have a good GPU, so it's going to be a little bit laggy. But we are seeing a lot of progress in the GPU markets, and if you have HTC Vive, for instance, that render a lot better because it can just draw those objects much more efficiently. Any other questions?
It's probably a bad idea, but I'm curious. Can you style all those AFrame tags with CSS?
That's a good question, and the answer is not really. So in typical game development, you have textures and object models, and so that's sort of how you would create something like really stylistically complex. You also have animations that are built into AFrame that we didn't cover because we don't have time. But if you want to look at that, the AFrame documentation will show you how to animate different things. And it's huh?
Yeah, I have an answer too for that.
Oh yeah.
Okay. Yeah, and actually, so AFrame's approach is a little bit different in that regard to ReactVR. ReactVR does use CSS to style, so you literally can use Flexbox to lay out modals in VR. So, and that's because ReactVR is powered by React Native, so it's the same kind of style experience. Any other questions? Yeah.
Have you built this for any clients, or is this more just experiment?
Yeah, we've done some pro bono work with clients, and so far their reaction has been really good. If you're interested in that, I would really encourage you to go talk to Todd. He's got a lot of info on that. Yeah.
Have you guys done anything using Unity game engine to do VR?
I've been playing with it. been making a fun game on the side, just on my weekend time here and there. No, I haven't published anything with it, but I find it to be very fun.
Repeat the questions, please.
Oh, yes, I'm sorry. You asked if we had been playing with Unity at all in regards to WebVR. CVR is actually really easy to get set up on Unity. You just sort of install the plugin, and that's it. Any other questions?
Editing is just like super cool for VR. Is that like, what is the, I'm curious about if it was a 2D editing experience. It was like, I mean, you're dragging around and then you're manipulating your controls in a 2D environment. Was that intentional because of just where technology is at, or have you explored editing in a 3D space?
That's a great question. And actually, so he's asking if we've explored editing in a 3D space as opposed to editing in a two-dimensional space where you have a VR thing printed on your desktop. Yeah, we have experienced that, or experimented with that, and we haven't gotten it to where we're comfortable saying we can absolutely do this, but since the WebVR component that's rendered in that editor is actually a WebVR component, you can theoretically take a controller and grab it and drag it around, because it's the same events that are sort of like causing those interactions on the computer than it is in the headset. So yes, that's something that we would like to work on, and we certainly want to be able to pop a headset on and edit the position of things. Any other questions?
Yeah, I have one. So maybe it was just because I was like paying attention 3/4 to that demo piece. But did you say you've done this with VR, with video too, or was it primarily those static VR spaces?
We've done most of our, the question is, have we worked with photos or videos mostly? We've done all of our work with photos so far, but I know that you can do videos.
I should have said time-based, not just video, but. Yeah.
Oh, time-based, is it like
video or
GIF, yeah. I know that it GIFs, however you say it, are supported. You can render them. We have not done that yet. I think we've been keeping things really light for performance concerns. Just because, yeah, those GPUs on the phones are not that powerful, but yeah, we want to play with it. Well, I think that's all the time we have. So thank you so much.